Okay, so we're going to solve valid parentheses. So a valid parenthesis is anything like this, or these combined, something like that. Everyone kind of knows what a valid parenthesis would be. So let's get into an example. Let's go with something like this. So this would be our string S. And you're given the string, and you just want to make sure your string is a valid parenthesis and the parentheses are true. So yeah, so in this, you'd use a stack to hold all of the open values, because when you hold an open value, the next closed value should always be correlated with the open value. So let's say you have this, two open values. The next closed value better be correlated with the top of the stack open value, as like so. And if it's not, then it would be false. So in this, let's write a stack to show the open values, and let's just go like that. And then you'd have a map or unordered map in C++, and this map would correlate all of the open and closed values. This is the value. This is the key. Sorry, this is the key, and this is the value pair. So you have pew, and then pew, pew. Cool. So that would be in the map. That's what you would search for. So you would want to search through every single index in the string that is given. And to do this, we'd want to loop through these and then compare. So you'd want to check if you find the value in this key. You would do a separate condition. Otherwise, it would be an open parenthesis if it's not in this in these keys. So you do if let's just say, so if parentheses are let's just call this map parens. If found in parens, you do a different condition. So otherwise, so else, you would do, you would push to the stack. You'd push to the stack. So yeah, that is kind of what you would do. So let's call the stack open, because that would be the open brackets, open.push. And then you'd push your current index, or current value at your current index in that array. So what you'd want to do first, so let's just start with the first value. This is an open index, so you found an open index. So it is not found in these keys. So you would push to the stack. So you push that character to the stack. Then going on to the second one, it is found in the key. It's found right there. So then you use this if statement, go through this if statement, and then you'd want to check if the open values are empty, because otherwise it would give an error. So if there's nothing in this stack right here, then it would not be valid, as it would just be closed parenthesis, and then you can return false right away. So if open is empty, then you'd return false. And then another condition that you'd return false is when your next value does not equal the top of the stack, or if you're in this if statement, does not equal the value in the top of the stack. So it's not correlated. Your value pair is not correlated with this, the associated key. So what you'd want to do for that, so if your parens at your current character in the string does not equal open dot top at the top of the stack. So if that is not true, then you'd return false. So if that is true, you'd return false. So that's kind of what you do. And then if your stack is not empty, if your stack is not empty and the correct values are associated with each other, then you'd pop from the stack. And then you'd never put the closed parenthesis in the stack. So in this case, so let's start with open is empty. Open is not empty. There is a parenthesis, and then if parentheses of s of I. So if this character does not equal open.top, it does equal open.top because you searched for this parenthesis in parens, and that is equal to that parenthesis, and that is equal to this. So therefore, would not return false, and then you just pop from the stack. So pop from the stack. There's no longer an item in the stack. Let's just make that clear. No item in the stack. So now you would move your index to the next one. And this, if found in parentheses, it is not a closed parenthesis, so you'd push to the stack. And then, so that's the open parenthesis in the stack. Then you go to the next value. This is not found in the parenthesis, in the key value parentheses. So let's just make that if found in parens. So then you'd push that value also to the stack. And then you go on to the next value. This is found in the parentheses. This is found right here. So you'd go through this, check if open is empty. There's two values in it. It is not empty. Then you check if parentheses does not equal open.top. So you find the character of your current index. It's here. And then you have your value for that. Is that equal to the top of your stack? Yes, it is. This equals this. So therefore, it would not satisfy either of these conditions, and you'd pop from the stack. So let's just erase that. And now that there's one value in your stack, and then you'd move your value, your index to the next value. This is found in parentheses. It is right here. And then if open is empty, open is not empty, there is a value in the stack. And then if your current character does not equal top.empty. So you found your current character in parentheses. So then you check if that value is equal to the top of your stack. It is. So you're done. You search the stack, and now the end of the condition would be checking to see if it's the last index of the string. So then you would exit out of that string, and then you'd want to make sure your value, your stack is also empty. Right now, your stack is empty. So you would return this, so you would want to check if your stack is empty and returning like your stack open.empty. So if your stack is empty, it returns true, else it returns false. But in this case, it returns true, so you'd return the value true, and that means your parentheses are valid. So in this case, it is true. A case where it would not be true, let's just say you have that open value. It would satisfy all the conditions, it would get out of the loop, and it would be false because there's currently something in the stack. So you'd be returning false. So that is how you would go about this problem. Now we want to get into the coding portion of it. So you'd have your stack, and this would be of your open parentheses. So let's just call it open, and then unordered map of two different characters, your open and closed parentheses. So let's just call it parens, and then let's write the parentheses. So you'd have that, and then you'd have all of the pairs of parentheses. So let's just quickly recopy that. Dun-dun-dun. All right. And then so we have our basic setup of what you need, and then you'd be searching through the strings. So we can just use a for loop. Okay. Now you check if your parentheses are found. So if your current parentheses found, so it does not get to the end of this. So it's either this, this, or this. You would go into that part of it, else it's an open parenthesis. So you just push it to the front of the value. Open dot push S I, and there you go. And then after this, you can return open dot empty to see if you're open. Make sure it's not just an open without a closed parenthesis. So there we go. So first you want to make sure there is a value in your stack. So open dot empty and return false if there's no value in your stack. Otherwise, you'd want to check if your parentheses match, if your parentheses match, so if it's correlated to the correct closed parenthesis, you would do this case. So if parens of S of I does not equal open dot top. So if it's not equal to the top of your stack, then you'd return false as well. Otherwise, you'd pop it from the stack because it's not there. You don't really need the else statement, but I felt like putting it there, so there we go. This probably should work. Let's see. Okay, and okay, there we go. That is the correct code. So